So these are the 11 things they're not telling you about the new era of quantum computing. Number 11. Quantum supremacy might already be achieved. Something that would have taken the world's fastest supercomputer, Summit, around 10,000 years. But IBM immediately pushed back, claiming the same calculation could be simulated on a classical computer in about 2.5 days. Since then, China's University of Science and Technology, USTC, has built two machines, Zhuzhang and Zhukongzi, that achieved similar results using photons and superconducting units. Number 10. Software is the real battlefield. When people think of quantum computing, they imagine shiny processors cooled to near absolute zero. They need specialized frameworks to control phenomena like superposition and entanglement. That's why companies like IBM created QuizKit. Google built Cirque, and Canada's Xanadu developed PennyLane, which bridges quantum and classical systems. According to McKinsey's 2024 Quantum Technology Report, global investment in quantum software has tripled since 2020, passing $2.1 billion. Even Amazon and Microsoft now offer cloud-based simulators for developers to test algorithms. Number 9. Cryptography could be the first real casualty. Every message you send, from bank logins to private emails, relies on encryption based on mathematical problems that classical computers can't solve quickly. But quantum computers can. In 1994, mathematician Peter Shor proved that a large enough quantum computer could break RSA encryption, the backbone of nearly all digital security. Governments know this, which is why the U.S. National Institute of Standards and Technology, NIST, has been working on post-quantum cryptography standards since 2016, finalizing them in 2024. Number 8. The global quantum race. Quantum computing isn't just a scientific milestone. It's a geopolitical one. China's Quantum Project 2030 is building a nationwide quantum communication network and already launched the Messiah satellite to transmit encrypted quantum data between continents. Private companies like IBM, Google, and Intel are working alongside governments, but national security interests drive most of the fun. It's the 21st century version of the space race. Number 7. Quantum's real impact starts in specific fields. Pfizer and IBM are using quantum computers to simulate molecular interactions that could accelerate drug discovery. Volkswagen and Airbus are testing quantum algorithms to optimize delivery routes, air traffic, and fuel efficiency. These are early pilots, but they reveal how quantum will first impact science and industry rather than consumers. According to Boston Consulting Group, quantum computing could add $450 to $850 billion in annual value by 2040. Number 6. The silent struggle with errors and instability. Quantum computers might sound futuristic, but they're extremely fragile. IBM, Google, and Quantinuum are working on error correction, but the math is brutal. Right now, it takes thousands of physical qubits to make just one fully stable logical qubit. In 2024, IBM's Heron chip reduced error rates by about 60%. Quantum decoherence, when information leaks out of the system, is still the field's biggest roadblock. Number 5. It's not about more qubits, but better ones. A 2025 Nature Physics study showed that qubit quality, how long they stay stable and how well they connect, matters more than raw count. IBM's 433-qubit Condor chip set records, but many of those qubits can't maintain coherence long enough for meaningful calculations. Google, Rigetti, and Atom Computing are now exploring modular systems that link smaller processors together. The race ahead isn't for the biggest chip. Number 4. The quantum hype cycle. Quantum computing is right where artificial intelligence was a decade ago. According to Gartner's 2024 hype cycle, quantum technology currently sits in the trough of disillusionment, the phase where inflated expectations meet harsh technical reality. Startups that once raised tens of billions in 2021 are now merging or downsizing as investors realize how difficult it is to stabilize and scale quantum hardware. IBM's 2025 roadmap even predicts utility-scale quantum systems within 2 years. So yes, the buzz has quieted, but that's often when real breakthroughs happen. Number 3, quantum advantage exists, but barely. You probably heard the phrase quantum advantage. Google's 2019 Sycamore experiment technically did that. Since then, IBM and Quantinuum have demonstrated smaller advantages in chemistry and optimized simulations. Quantum advantage exists, but it's fragile, expensive, and far from changing your everyday life. Number 2, the quantum investment boom isn't all gold. Quantum computing has become one of the most heavily funded tech frontiers of the decade. McKinsey's 2025 Quantum Report estimates over $35 billion in global public and private investment, spanning more than 350 startups and research ventures. Number 1, quantum computing won't replace classical computers. Microsoft's Azure Quantum and Google Cloud's hybrid frameworks already let developers run quantum and classical tasks in parallel. If you made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.